Okay, Mr. Gazda here. Homework 101, Metamorphic Rocks. You need a reference table with you. Here we go. Contact metamorphism is when rock is changed by high temperatures but not high pressure. This occurs when rock is in contact with lava or magma but is not buried very deeply. So we often say it kind of gets, often gets cooked by lava or magma, but it doesn't really have that high pressure that many metamorphic rocks need to form. Regional metamorphism is when rock is changed by high temperatures and high pressure, and this occurs when rock is buried under other rock. Okay, so both heat and pressure, and that's because one large region of rocks gets buried at a time. So it means one whole region was under 10 miles of rock. So use the reference table to complete the matching column below. So our choices are regional metamorphism only, contact metamorphism only, either regional or contact, or not a metamorphic rock. Use your reference table here. You're going to look in this column right here. All of these are regional. This is regional anthracite coal. These down here, quartzite marble metaconglomerate, can be either. And the contact metamorph is hornfels. That's the only way that one forms. So if you haven't done it yet, do those now and then come back and check your answers. Okay? Pause this, make sure you have those done, because the goal here is to check your answers, and I'm going to write them down shortly. Like now. So, hopefully you have this done and you're checking your answers. A, D, B, C, C, D, A, A. Okay. Sometimes they're not a metamorphic rock ones, but if it's not on that chart, and actually these are on these, this is on the sedimentary chart. This is on the igneous chart. So in the reference table. Here we go. Banding forms in some strongly metamorphosed rock. This is an important thing here. When under very hot temperatures and high pressure, a rock will partially melt. Again, similar to thick toothpaste. Peanut butter is the other thing. What it gets like. The minerals will move or migrate within the partially melted rock. When they move, they tend to group with similar minerals. And I often say, like, all the quartz will kind of move together, and then the pyroxene moves together, and the mica will move together and form these different layers of them. We see this in the rock as different colored layers that form perpendicular to the direction of pressure. This is called banding. Do now. Draw in banding of the black mineral on the metamorphic rock below. So this is igneous rock. This is how it starts out. The minerals are kind of random. Then you have pressure that kind of pushes down like this, okay, from the top. How would those minerals change in this partially melted liquid? If you haven't done it, do that now. Okay, then I'll show you how you go about doing it. But you want to do that, and then check your answers. So pause this and do it now, and this is what you'd basically get. Okay, first of all, the one thing you'd have is they would all be perpendicular to pressure like this. Okay, and then there'd probably be another layer here, for instance. Something such as that. Okay, just layers, and they're going to be like the long way, perpendicular to the pressure. The pressure's this way, and your layers go like this. That's key. And when it's different colored, it's banding. You should really, I'll do it here, you should color these in to show that this is like a black layer within the rock, or a layer of black minerals perhaps. It doesn't look exactly like it because it's just a hand-drawn thing, but hopefully you get the point of that, because that's what this is about. Next page. The more deeply a rock is buried, the more strongly metamorphosed it will be. This is due to the fact that the deeper a rock, the higher the temperature and the higher the pressure conditions. On the chart below, fill in blanks A to D with the correct rock. Not all rocks in the rock bank will be used. Here's the rock bank. You won't use all of them. Some of them won't be used. And it goes from clay to rock A, to slate, to B, to C, to D. This is all the sedimentary rocks form here. Metamorphic zone of rocks form right there. Okay, so notice this is surface. As you go down, the pressure is going to get more, and then as you go this way, the temperature gets hotter. It's 1100 degrees Fahrenheit. So the best thing to do is to look at your reference table. Look at your reference table here. That's going to help. I'm going to say, do that now. You see slate here, so you're going to have to use these things here to help you. Do that now. Make sure you have it done, and then come back and check your answers with what I got, and I'll show you how to do it. So, So here we go. Clay deposits will form what? Sedimentary zone has to be sedimentary rock, and then that will lead to slate. So clay, what sedimentary rock is that? Clay is shale. Another way to check is that it says for slate, low-grade metamorphism of shale. So shale is the parent rock of slate, and then once it gets into the metamorphic zone, it becomes that. So this should be shale. Cross that off right there. And then from slate, slate will become what rock, will become what rock, will become what rock. So if you look here, regional heat and pressure increases. So this is sort of the order that these rocks will form as you get more and more metamorphosed. This is a slight metamorphism of shale. This metamorphoses more, and the most. Okay, so it goes in this order: slate, phyllite, schist, gneiss. As it gets buried deeper, more pressure and hotter. Therefore, slate, phyllite, schist, gneiss. Okay, that's how that goes. Draw a point this size at a depth of 16 miles and a temperature of 1600 degrees Fahrenheit. Label it point G. And what do you think? Why do no metamorphic rocks form at the conditions at point G? Do both of those right now. Okay, don't watch me do them on your own, and then check your answers with me in just a minute. Okay, I'm going to do the B. It's just you reading this chart. 15 is here, and then 16 is probably here, 17 here, 18 here, and then 1,000. Oh, 1,600, I'm sorry. So that's 15, that's probably 16, 17, so it's probably something like, I'm just estimating, maybe that's 16, maybe that's 1,700. Am I doing, so maybe it's like right there. Label it point G. Okay, then it asks, what do you think? Why do no metamorphic rocks form at the conditions at point G? I'm going to have you think about that. I don't want to tell you the answer. Use some common sense. Check out this chart. What do you think is meant by this? Do that on your own. And I'm going to jump ahead to 11. Match the rock characteristics with the rock type in the matching column below. So we have metamorphic, igneous, sedimentary, where you cannot determine from the information provided. So, rounded rock pieces. No, rounded rock pieces is sedimentary. C. Made of minerals. You can't tell because all of these are made of minerals, so this is going to be D. Form when the parent rock is partially melted. Ooh, parent rock partially melting. No, that means metamorphic rock. That's metamorphism. Small holes from gas pockets. That's vesicular texture. Hopefully you can remember seeing those. You got to know that that's igneous rock. That's B. Form when mud is deposited ocean floor. Mud settling out of water, ocean floor, sedimentary rock. C. Used as a building material. D. Cannot determine from information provided, because all these different rocks can be used as a building material. Classified as plutonic. If you don't recognize that, look around on the reference table. It's only this page, and then this is plutonic right here. Okay, intrusive means it forms inside the earth, igneous rock. So plutonic is igneous. That is B. High concentration of mica minerals. High concentration. 40, 50, 60% of the rock or more is made of mica minerals. That is metamorphic. Okay, all rocks can have some mica in them, but the high concentration is metamorphic because part of that process is minerals changing over to mica. Sorry if that's off the page. I apologize for that. Can form when large water body evaporates. That's the crystalline sedimentary rock. It's an evaporite or precipitate, from water evaporating. We probably saw that in class. So that's going to be C, and may have fossils. C, sedimentary rocks as well have fossils. Okay. Here we go. Measure the diameter of the particle below. Okay, measure that, and I'm going to tell you, get your reference table ruler out, measure it like from there to there. That's probably the best way to do it. So most people do. Measure that. Make sure you put units on it. In what category of clastic sediments would this particle belong? So, in what category, it means this. You would need to get your measurement, and let's say you measure it to be 5.8 centimeters. It's not that. Let's just say, example, let's say you get that. What centimeter? You would look here. You would go in this chart. It's on page 6 of the reference table, and what you have is Anything below this size is clay. Silt is within here. Sand is here. Pebbles here. Cobbles here. Boulders here. You find your number, whatever you get, see what range it's in, and you write that on that line. Okay. 2. Number the following process lead to the formation of sandstone in the order they occur. What's the first thing? Well, read them all first. Compacting and cementing of sand grains, deposition of sand on the bottom of the body of water, burial of sand under more sediment. So, first, sand has to be deposited, then it has to be buried, then it has to be compacted, cemented. That's the process. Explain how an evaporite sedimentary rock forms, such as rock gypsum. I'm going to have you do that. Do your best. We saw the video in class. I evaporated salt water. I did it as an example in my kitchen. If you want to watch that video, it's on this YouTube channel. Search under rock salt. Excuse me. And you can do that. Here we go. 4. For each one, it's either going to be a sedimentary rock or igneous rock, or describe that best. No other choices. Okay. Do those. Do these right now. Don't just watch me do it. You can check back in a second and check your answers with mine. Okay, hopefully you need to have had this done. Form when an ocean evaporates. That is sedimentary. Usually have angular intergrown minerals in no order or pattern. Igneous rock. Know that as a rounded grains. Rounded grains is sed. Form when molten rock cools. That's igneous. Key to being igneous rock. Small holes from gases get trapped as the rock formed. That's called vesicular texture. So that's igneous. Know that. Are organic. Only sedimentary rocks can be organic. Means from a living thing. That means, coal is a good example of that, made from compressed dead plants. May contain fossils. Sed. Usually form at the bottom of large bodies of water. Sedimentary rocks. That's where the sediments pile up, and then it gets piled up some more, compacted, cemented. Also said. The last one, classified as plutonic or volcanic. See that here, plutonic here. Igneous rocks that formed inside the ground. Volcanic to form out on the surface of Earth. So that's igneous. Okay. On the back. Okay. Here we go. So what you should do, make sure you have do all of this right here. Do all 5 and 6 right now, and then come back and check with me, please. Okay, so here we go. You want to use this chart of the reference table for all of them. You want to use this chart for all of them, okay? So, 0.14 centimeters. And sometimes it's hard with the decimals. 0.14. It's close to this, so that's considered sand. Okay, 0.0051. 0.0051, that's less than that in between here. So these decimal numbers drive people a bit crazy. So the sediment's called silt. 12.5 centimeters is between 6.4. So that's going to be a cobble. 0.0002 centimeters. 0.000, that's supposed to be less than that, so that's clay. 34.0. That's greater than that. Anything above that's called a boulder, so that's a boulder. And then, sorry, 3.2 is going to be here. That's going to be a pebble. What type of sedimentary rock bubbles in acid? Well, what do we know about bubbles on acid? We have to know the mineral that bubbles on acid. You can look on the back of the reference table. Bubble on acid, look around. Bubbles in acid. That mineral is calcite. Therefore, what sedimentary rock has calcite in it? Look under the composition column right here. Look for calcite. Calcite, limestone. That's your best answer. Limestone. You can maybe say dolostone, but that would have to be scratched. But limestone and dolostone, I guess. But limestone is really the answer that most people arrive at. Why does it bubble? Basically because it contains calcite, and calcite bubbles. It's made of a mineral that bubbles in acid, which is calcite. Let me try to speed things up here a little bit. So draw the map symbols for each of these rocks. Conglomerate, that's the map symbol. Okay, you draw it in there. Siltstone, that's the map symbol right there. And we're going to use it later on in the year. So it's like this. It's like a dash, a dot, a line, a dot, a line, a dot. And it kind of goes like this. Do a good job of it. See, I'm taking my time here. I'm drawing it carefully. It needs to be very clear. And dolostone if you look, it's here. It's like a brick wall but slanted. Limestone's a brick wall but straight, so make sure that they're slanted. I usually kind of go like this, and like this, and like this, and then I carefully. No, I'm sorry, I should go like this and like this. Sorry, see, I kind of made a mistake. I'm in a bit of a rush here, so. But that slanted line. Do a better job than me. You'll have more time. I'm trying to get this video to not be too long. Which of the following is made of the smallest sediments? Shale, conglomerate, siltstone, sandstone. You want to look here. Grain size here. Notice these are pebbles and cobbles. These are large. There's the sizes here. You can recognize that this gets smaller as you go here. Shale is the smallest. Shale is the smallest. What type of sedimentary rock can be composed of shell fragments? You got to look around. There's not a lot to the sedimentary rock, so you know you're looking here. Cemented shell fragments. Limestone is the answer. Limestone is the answer. And what is the main difference between conglomerate and breccia? So look here and just see what it's going to tell you. I don't expect people to have that memorized by any means. Same size, both clastic, made of other fragments of broken other rock, but rounded versus angular fragments. That's key. Conglomerate is rounded, breccia angular. Excuse me. So that's key. Write a complete sentence there. And then I'll have you answer these here. Do your best to fill these out on your own, define each, and see what you get for this. Maybe your notes will help you a bit, but hopefully this stuff's out of your head, and good luck with that. Mr. Gaddis, for homework 102, doing homework 102. Thank you very much for watching, signing off.